Hello, welcome to section 4.7, where we're talking about graphing systems of linear inequalities. And remember, in a previous section, we learned how to graph linear inequalities just on their own. So now what we're going to do is we're going to be graphing two of them and see if there is any intersection. So let's get into that first. So first of all, and just FYI, remember what an inequality is? It's a line somewhere, and then where half of it was shaded. So let's say this was it has an inequality symbol. Let's see what else. And then if you have two of them, you have what's called a system of linear inequalities. And, their intersection is what we call the solution, okay? So basically, the solution of a set of linear inequalities is a set of all these points that fulfill both inequalities, okay? So it kind of looks like this. But first, in order to do your homework, you need to know how to determine if something is an ordered pair if an ordered pair is a solution to a certain system. So here we have x plus y is greater than or equal to 10, 4y, 3x minus 2y is less than 12, and we want to know if this point is a solution. So let's go ahead and plug that in. So we get negative 2 plus 4 times 4, and we're asking, is this greater than or equal to 10? So here we have negative 2 plus 16, greater than or equal to 10, and it is. Negative 2 plus 16 is 14. Is that greater than 10? Yes, so it fits the first equation of the system. So now we need to check the second equation of the system, yeah? So, okay, fine. So 3 times negative 2 minus 2 times 4. And we're asking if it's less than 12. So we have negative 6 minus 8. And we're saying, is that less than 12? Negative 14, yes, that is less than 12. So this is a solution to the system, this ordered pair. So yes, okay. And now let's go ahead and try the next one. So we're going to plug it into both. So 3, 1. So x is 3, y is 1. So we have 3 plus 4 times 1 greater than or equal to 10, question mark. 3 plus 4 greater than or equal to 10? No, because that's 7, and 7 is not greater than or equal to 10 today. So not a solution. Okay, so that's how you would solve that type of problem. Again, so just like I showed you, here it is in words. To solve a system of linear inequalities by graphing, first of all, you graph the first inequality. Remember, you need to graph the boundary line. If it's a strict inequality, meaning it doesn't have the line underneath it, it's a dashed line, right? And then we need to shade the side that makes the inequality true. And then we graph the second one, and the solution is the region where the shading overlaps. Okay, so let's go ahead and graph both of these. So first of all, we have here y is greater than or equal to 2x minus 1. So this is, just by looking at this, I know, okay, the slope is 2 of the boundary line. The y-intercept is negative 1. And then you have that it's going to be a solid line because you have this line right here, greater than or equal to. So let's go ahead and graph this line. So we're starting at negative 1, and then our slope is positive 2, so we go up 2 and over. Remember, that slope is rise over run. So from our starting point, we go up 2 over 1 dot, up 2 over 1 other dot, up 2 over 1 next dot. So, you didn't have to put that many, but you guys get what I'm talking about. Okay, so so we've graphed the boundary line. So now what's left is to say, okay, well, what side do I shade? So I'm going to go ahead and choose a test point. I'm going to choose the origin, easiest test point, to plug in. Remember the origin, 0, 0, and we plug that in and see if it's true or not. So we're basically asking the question, is 0 greater than or equal to 2 times 0 minus 1? So is 0 greater than or equal to negative 1? And yes, it is. Okay, great. So that means we shade the side that includes a test point. So we're going to shade all this side. And you don't have to color it in or anything. I'm just being super extra right now, but just to prove my point. Okay, so let's do the next one. So this one again is the line is y equal to 2x minus 1. But the entire inequality is greater than or equal to. So the blue part. Okay, let's do the next one. So we have here y less than, strictly less than, right? Because there's no line here. No line here, right? So it's a strict, we call that a strict inequality. And let's go ahead and graph that. What is the slope of that? What's the coefficient of x, of course? So that's 1 over 1. And the y-intercept is positive 1. So that's where we're going to start. We're going to start at positive 1. You know what? Maybe I'll use a different color. We'll start at positive 1, and then we're going to go up 1 over 1. So up 1 over 1, and that's the next point. Up 1 over 1, and that's the next point. Up 1 over 1, and that's the next point. Here, wait, I think sorry. Up 1 over 1, up 1 over 1, down here. Up 1, and then over 1 here. Okay? And it just continues like that. So we have here, let's see, this is 4, so this should be over here. Down over 1, okay. Yep, and then the line goes through here like this. Okay. And then what side do we shade? So now we have that. Well, what side are we shading now? We're shading, let's test the point. So let's test the origin. So the origin is 0, 0. So we're going to test that point, 0, 0, and plug it into this equation here. So 0 less than 0 plus 1. Is that true? Yes, 0 is less than 1 today. So that's true. So what that means is I'm going to shade the side that includes that test point. Okay. So I'm going to do that. So the side that includes the test point is this side. Oh, and then one thing I forgot, this is a dashed line, right? It's not a straight line. Okay, let me go ahead and fix that. Okay, so, oh, geez. Okay, so, small eraser, does that work? Okay. Oh, I don't know what I just did. Oops. Okay, so, maybe to indicate that it's dashed, sorry, I'm just going to go like that, okay? Because I don't know, I don't want to like mess up all the work I just did. Okay, so it's dashed, okay? And so the answer actually is this region right here, like all of this, you know, this part right here that's shaded together, okay, where the shading intersects, okay? So that's it. That's the answer. That's the system, you know, solving it by graphing. Let's do another one. Okay, here we have x minus 2y less than 5. So we have x minus 2y less than 5. So it's not in slope-intercept form. So let's go ahead and put it in that form. So subtract x from both sides. Negative 2y is less than negative x plus 5. Divide both sides by negative 2. What happens to an inequality when we divide by a negative? If you said flip it, you are right. Good for you. So that would be 1/2 x minus 5/2. Okay, so the slope of the boundary line is 1/2. The y-intercept is negative 2.5 or negative 5/2. So down here. And then it's going to go up 1 over 2. You know, up 1 over 2. Up 1 over 2 like that. And then that's going to be a dashed line, because it's a strict inequality, remember? Dashed. Okay. All right. So now what side do we shade? Let's go ahead and use a test point. Okay, so let's try 0, 0. We can plug it into this. So 0 minus 2 times 0, is that less than 5? So yes, 0 is less than 5. So we shade the test point side. So we shade up here, the side that includes the test point. So that's that. That's super fun looking. Okay, so then now let's do the next one here. Y greater than negative 4. So that's not too bad. So we just go to negative 4. 1, 2, 3, 4, and it's just the boundary line is just y equals negative 4, but it's dashed, of course, because it's a strict inequality. Okay, this is a terrible drawing, by the way, but you guys understand, I think. Okay, so yeah, so this is the boundary line, y equal 4. And it's greater than. So everything that is facing up fulfills this inequality. So like if you put in 0, the origin point 0, 0, y greater than, is 0 greater than negative 4? Yes, it is. So we shade everything that's above the boundary, that line right there, that boundary line. So our solution is here where they both intersect. It's this area up here. And you can maybe pick another color if you want to be super extra about it. You know, it's fine. It's your world. You can be as creative as you'd like. Okay. Yeah, so that's the solution right there. And the rest is not. Even if you might think, well, it's colored, but it doesn't include both. It has to include both for it to be a solution. All right, so that's pretty much it. I think, so just to recap, you put them into y equal mx plus b form. You graph each one. Don't forget to check if it's solid or dashed. And good luck. Your test points, okay? And shade each one maybe different colors or different types of shading. And then where the shading intersects and it's, the two shading intersects, you can keep that. And if you want, you can erase everything else. Okay, good luck. Here is your homework assignment. Happy studying, and I will see you on the next video.